Hi everybody, I'm Greg Fishel and welcome to bonus weather video number 1 for this week. And we're going to talk about the sunrise and the sunset and why the latest sunrise and the earliest sunset do not occur on the shortest day of the year. You would sort of think logically that the two would converge like this to the first day of winter, the shortest day of the year, and then they would both symmetrically spread farther and farther apart as we head into the spring and summer. But that is not the case, and there's some good reasons for it. So we're going to explore some of those today, and we will do that right now. Okay, so interesting, huh? The red line is the sunset time, okay, and the blue line is the sunrise time. Now, notice that the earliest sunset in Raleigh for this year occurs about December 5th or 6th at about 5:02 p.m. The latest sunrise occurs about January 6th and 7th at 7:23 or 7:24 a.m., depending on how you want to round that off. But the shortest day, where those lines are closest together, is December 21st. So why is that? Well, there are a number of reasons. First of all, this may surprise you as well, we are closer to the sun during the winter. The Earth has an elliptical orbit around the sun, and we're closer to the sun during the winter in January, and we're farthest away during the month of July, which doesn't make any sense, right? It's like, oh, okay, the closer I put my hand to a hot stove, the cooler it's going to feel, okay? Well, it turns out there's another thing that's coming into play here, and I'm going to go off on a tangent here for just one slide. It turns out that the sun's elevation angle trumps any distance the Earth is from the sun. For instance, on June 21st, the sun is 77 degrees above the horizon. 90 degrees would be directly overhead. So those rays are much, much more direct than they are on December 21st, when the sun is only about 30 degrees above the horizon. Think of it this way. If you have a flashlight and you shine it directly in somebody's face, they're going to notice that, okay? But if you shine it at an angle to their face, then the light is spread out over a greater distance, and they're not nearly as cognizant of the fact that you are shining a flashlight toward them because the angle is shallow and it just isn't all that direct. And so again, even though the distance from the Earth to the sun varies by about 3 million miles, this angle of attack, if you will, is much, much more important than that variation in distance. All right, so let's get back to the primary purpose of this video, why the latest sunrise and earliest sunset do not occur on the winter solstice. And it has to do with something called the equation of time. And if you really want to delve into this, do a Google search for equation of time, and you can get as basic or as advanced as you would like to on this topic. So here is a graph of the equation of time, and you can see that the red line represents the difference in minutes between a solar day, if you will, and the kind of day that we, think of from a conventional time standpoint. And so let's delve into that a little bit more. Two factors here that make up the equation of time. First of all, as we've already mentioned, the Earth's orbit is elliptical, so the Earth moves fastest around the sun in January when we are closest to it, and slowest around the sun in July when we are the farthest away. And the Earth's axis is tilted, so from any given point on the Earth, that point is moving on a plane that is tilted 23.5 degrees from the orbital plane. So think of it this way, is that the Earth is actually, the center of the Earth is rotating in a plane around the sun, but because the Earth is tilted from the perspective of any one given spot, that plane, instead of being like this, is actually tilted 23.5 degrees. And so those two factors go into making up this difference in time as to where the sun appears in the sky and the way we measure time, which is one rotation of the Earth, which takes 23 hours and 56 minutes. So a solar day is defined as the length of time necessary for the sun to reach the same position in the sky from one day to the next. And that is not always 23 hours and 56 minutes. In fact, there's only, 4 times during the year that it is, and the rest of it varies by as much as 14 or 15 minutes. A day to us is the length of time it takes for the Earth to make one full rotation, 23 hours and 56 minutes. But again, a solar day can vary by as much as 14 or 15 minutes from our definition of a standard day. All right, I hope that makes a little bit of sense. And again, if you really want to get into this deeper, just do a Google search for the equation of time, and there are a whole bunch of different articles and videos out there that really delve into the details of all of this. And so if you are masochistic like I am, and you're really into the science, then you might want to check that out. All right, that's bonus weather video number 1 for this week. We'll have another one coming up for you on Friday. And a daily weather update will be posted hopefully within about an hour to an hour and a half from now. And now it's about 3:30, so by 5 o'clock. That is the goal, to get that out, and we'll have the latest on this Arctic cold wave that'll be heading our way for the Christmas weekend. Okay, that's it for now. Have a great Tuesday evening, and we'll talk to you shortly.